Good day, YouTubers. Welcome back to another video with the electrical guide. Today, as promised, I'm here to show you how to solve a simple series circuit. So I'm going to give you a quick tour around my screen here and then we'll get started. So first and foremost, I think having a table to log your values is the most important factor in solving electrical circuits. I think keeping your data clean and organized and visible is just a make or break in the more complicated circuits. So we're going to start with this habit nice and early, even with the simple series. I have my series circuit rules here as well, and we'll be talking about these as we go through the circuit. I have, of course, my circuit visual right here, and we are using the negative to positive electron flow rules. So we have R1, 2, 3, and 4 here in a loop. And I've got some Ohm's Law values down here, just making our triangle, our Ohm's Law triangle, kind of spread out to show you all the different variations we'll be using today on the bottom left. So, without further ado, let's get into solving this. The values we have, in the interest of time, I've already preloaded into our table, R1, 2, 3, and 4, as well as our voltage total of 24 volts. Given that we have our resistance 1, 2, 3, and 4 values, we can look to our series circuit rules, and resistance adds up. So it's the sum, right? R1 plus R2 plus R3 plus R4 is going to give us that R total. So RT is going to be R1 at 0.4 plus R2 at 1.7 plus R3 at 0.67 and plus R4 at 1.1 ohms, giving us an R total of 3.87 ohms. And we're going to immediately enter that into our chart here just to keep our data clean. What can we do next? Well, Ohm's Law tells us if we have any two values, we can solve for the third, or in this case, if we have any two in our blocks up here, and I've isolated these kind of into total and resistance blocks, we can find any of the remaining empty ones if we have two values. So we have two values here. What can we do with V and R? Well, we can find our current total, which is I equals VT over RT. So IT is going to be 24 volts total over our resistance total, which is what we just found out at 3.87 ohms. And our I total is therefore going to be 6.2015 amps. And we're going to right away toss that into our table over here. Now that we have our current, we can solve for power, and power is going to be V times I. Now for solving for total, again, we have to use the total values for voltage as well as current. So our PT is therefore going to be 24 volts times our current total we just found at 6.2015 amps, giving us a power total of 148.836 watts. And we're going to throw that into our table again right away. Okay, what can we do next here? Well, let's consult our series circuit rules. According to our rules, current is the same through each resistor as it is with the total. I1 equals I2 equals I3 equals I4 equals IT, which means we have IT, so we can simply just transpose this across our current values for the resistors. So I'll do that now quickly. Okay, we have all our current totals in. Now, if you recall, any two values, we can solve for the rest. So we don't actually even need to look at our circuit anymore. We can do all the rest of our calculations just with the values here in our chart. So I'm going to quickly process V1 here to show you how this works, right? V1 using Ohm's Law would be I1 times R1, V1 being unknown, I1 being 6.2015 amps, times an R1 value of 0.4 ohms. Now you can see how easy it is to pull these when they're just right there in your chart, right? Leaving us with a V1 value of 2.4806 volts. Now I want to include 4 decimal places if they're available for every calculation I do when I'm solving electrical circuits, and I'll show you why that's important at the end. You'll notice I did that also with my current value. There were many more in the calculator, but I just wanted the first 4. So I'm going to go ahead and do the rest of these voltage calculations quickly, and I'm going to speed it up. Okay, now that we've found all of our voltage drop totals across each resistor here in this series circuit, we can go and solve for the power totals as well, and I've included that on the bottom here, P equals V times I, so power equals voltage times current, and we measure power in watts. So I'll do the first one, times I1, so P1 equals our voltage 1 of 2.4806 volts, times our current one, which is of course always the same, giving us our P1 of 15.3834 watts. And of course, I will immediately throw that into our table. And I will quickly fast forward while I process the rest of these. Okay, we have solved for all of our values in our series circuit here. Nice and easy to see because we filled them all out in our table as we were going. Now there is one quick and easy way we can verify these answers are correct, and that is by taking the sum of our power values across each resistor and comparing it to our total. Now I've been taking 4 decimal places here, as you can see from our last example, and I'm going to show you now why I think that that is important. So I'm going to do a quick addition here of our power values. You can follow along. I'm going to speed it up, and we're going to talk about it after. Okay, and that gives us 148.8321 watts. Let's compare that to our total here. We got 148.836. So we are accurate to a difference of 0.004 because we have a 2 in our third spot here and we have a 6 in our third spot here. So by using 4 decimal places throughout this entire process, we've been able to maintain a very close accuracy when we check our answers, right? So these values will never quite be exact because we don't include every single decimal that shows up in the calculator. At some point we have to kind of cut it, and I think 4 decimal places is where we get a decent amount of accuracy without getting ridiculous. So basically if we get our P1, 2, 3, and 4 and it does add up to our power total, that guarantees that all of our voltage and current that we use to find those powers must also be correct. So that pretty much tells us every value that we've just calculated must be correct if we're getting an answer that's this close to our power total. Okay, thank you for watching another video with the electrical guide. Please be sure to like and subscribe.